and graphing arithmetic sequences, the code's right here, JNMJJT. That's probably one of the more difficult ways to get to it, but that works, okay? And this goes with textbook lesson 4.1. Your EQ is what is a sequence and how are sequences and functions related. Your learning goal for today is I can identify a rule for an arithmetic sequence that models a situation. So we're going to take what we already know about functions and we're going to build on that knowledge and learn about sequences and then see how they're related. So we'll start with some vocabulary so we know what we're talking about as we say these different words. When I talk about a sequence, okay, we're talking about a list of numbers or objects in a special order. And an arithmetic sequence is it's where the difference between one term and the next is a constant. And if you remember, a constant is another word for a number. Okay. In other words, we just add some value each time onto infinity. And the term of a sequence, that is an element or a number in the sequence. And so right here in this image, we have a sequence. It's 3, 5, 7, 9, and then you have these 3 dots, which means it goes on forever. So this is a list of numbers, and it's in a special order. Okay, it's an arithmetic sequence because the difference between one term and the next is a constant. We're always adding the same amount each time. Okay, and then the term of the sequence, we can refer to the first term as the first number that shows up, the second term as the second number that shows up, and so on. Okay, as you get further out, and you can say in general like the nth term, that would also mean that. So, you know, in the chat, you can, if you know, you can type what is the constant what we're adding each time in this sequence. 3, 5, 7, 9, 11, 13, 15, 17, 19. What is the constant that we add each time? You're right, Matthew, it's 2. Okay, so Jasmine, did you get the code? I'm going to check because, you know, I mentioned it. Yes, you did. I see you did. Okay. Good. And so when we talk about sequences, they're similar to sets. And we've worked with those before, okay? The difference is that in a sequence, the terms are in order. When you have a set of numbers, it doesn't necessarily matter the order. Also, with a sequence, the same value, the same number can appear multiple times, whereas a set, you wouldn't repeat a number that shows up more than once. Okay, sets are things like the domain, the range. We worked with sets when we were working with statistics last semester in Triad 1. All right, so here's an example that this is a sequence, and we have these curly brackets, and then inside we have a list of numbers, 0, 1, 0, 1. Okay, so on, and we have these 3 dots, which means this keeps repeating forever. It's alternating zeros and ones. Now, if I was to write this same sequence as a set, I wouldn't repeat any of the values, okay? So I would say the set of numbers that is shown here is in the curly brackets, just 0 and 1. So they're a little bit different, but they are also similar. The notation with sequences, okay, is the same as set notation. We list each element separated by a comma, okay, and we put the curly brackets around it. And that's what you can see here. So this is a sequence here. And we can also call these curly brackets set brackets or braces. They're on your keyboard. On my keyboard, they're next to a P, letter P. Okay, and so for this first interactive slide that we're going to do here, It says complete the table and state the domain and the range for the sequence. So as we work with this sequence, we're talking about things that are familiar already. We're talking about domain, we're talking about range, tables. Okay, so these are familiar things to us. And this is number one, it's done for us. We have this table of values. We have the n's, which are 1, 2, 3, 4, 5. And then below that, that row is f of n. Now this is function notation. If you remember functions, when we would replace, instead of having x and y, we would have x and f of x, right? And so similar here, we have n and f of n. So this sequence is actually also a function. And the inputs, you could think of them, are 1, 2, 3, 4, 5, which are also known as the domain. And the range, or my outputs, are 3, 6, 9, 12, and 15. Okay, so there is a pattern here. And if you're trying to identify it, you know, you could think of it as to get from 3 to 6 to 9 to 12 to 15. We're adding the same amount each time. All right. Well, how much are we adding on this first one each time? You could type it in the chat if you know how much we're adding on this sequence. What is the difference between each f of n output? So for the row of n's, yes, we're adding 1 each time. Okay, these are integers increasing by 1. And then for the row of f of n, yes, we're adding 3 each time. Okay, and these are increasing by 3 each time. All right. And so now what you're going to do is number 2. Okay, so now you're going to go to your Pear Deck tab, and this is where you can draw on a slide. You can, typing is probably the easiest. You're going to fill in these empty boxes, and then you're going to list out what the domain and the range is. So n, we're starting with 1, 2, blank, 4, blank. You got to fill in the blanks. And then f of n, 10, blank, 30, blank, 50. What goes in these empty boxes? Type it in and then list out the domain and the range. Okay, so at this point you should toggle over to your Pear Deck tab and answer it. Answering these slides, this is also how you get your full attendance credit. Okay, so if you want to be engaged, how do I phrase this? So in Aries, if you're not engaged, it means you're not participating. I'm asking you to do something, so everybody should be doing this. You need to. It's required that you participate in the Pear Deck. That's how you get marked as present. You can't see anything on the Pear Deck. That's interesting. I can't see your screen, Samantha, so I'm wondering if you're in the right one. Let me see if you were showing up in mine. Okay, good. I'm glad you're able to join. So at this point right now, there's still 1, 2, 3, 4, 5, 6, 7, 8, 9 of you that haven't started typing anything or writing anything. So you do need to start that. I have 17 out of 26 responses. So I'll give you about another minute, okay, to fill this in. Can I open it for you? I can send you the link. Yeah, basic. Isaac. Okay, I just sent you the link, so copy and paste that into a new tab. Oh, it's possible that it's lagging. So, you know, do the best you can. You can still, so when class is over, and I want to see who participated in this, I understand that would lag on some of you guys. So, you know, I wait till we're in our asynchronous time to go back and check the slides to see who participated, just because of that reason. All right. So make sure, you know, if your computer is going slow, you only want to have, this is just a general statement, you only want to have the Google Meet and the Pear Deck open if things are running slow. Okay, and then if you still can't get the Pear Deck to load, when you leave the Google Meet, then, you know, go back to the Pear Deck and just focus on getting that part done. And if it's still lagging, send me a message through GoGuardian so I know exactly what the issue is, because that is excusable if you know, your internet's just not working very well. I wouldn't know that unless you does it still show the work if you're doing it on another computer? So it should show the work. Okay, so like I saw your name, Arabella. Yeah, it shows your work. It's working. So the thing about being on a different computer, so when I'm in GoGuardian, I'll just show you this. So like if you come back to the Google Meet, you want to see what I'm looking at. So this is my view in GoGuardian. And so only those of you that are logged into your Chromebook, I can see, you know, which tabs you have open and which screen you're actually on. This is how I'm able to help you with a lot of your work. If you're on a different device, I may not be able to see this, but what I can do is come to here where I can see everybody's name and their work, and I can see who hasn't responded or who has responded, and it's like a teeny tiny picture of your work. All right, so I have lots of ways to see what you're doing. It gets confusing because it is a lot going on. I'm going to come back to the Pear Deck presentation through Google Meet. So what I'm going to do now is, if you guys can come to the tab with the Google Meet, and you know, sometimes that's a little frustrating to have to toggle back and forth between the two tabs. Like I'm in the tab for Pear Deck, and then I'm in the tab for the Meet, but maybe I'm missing something in the Meet while I'm working in the Pear Deck. You can actually pull those tabs out and then resize so you have two open windows next to each other on your screen. And then that way you can see everything that's happening at the same time. That's an option for you. So anyhow, I'm going to show some responses here. I got 23 out of 29 people to respond so far. 29 people have joined, and there are 30 in the Meet. So we're really close to having everyone join the Pear Deck. There's one more person that needs to join. So I'm going to show some responses here. And so this person, they have the correct domain and range. I did want to see these boxes filled in. This person got it all correct. Good job. They got it all correct. Nice work. We added some color here. I like that. A little pizzazz. Good job. Okay. And so that's one thing you can do too. So like everyone's work here, like this looks exactly the same as this, but if you want to see your work stand out, you can add some color to it, and then you would know when I'm showing it. If you wanted to, I don't know. That's something I would probably do. And then there's another correct one. Okay, and here's another one. And this person, they added in a little notes right here. They're saying like, hey, we're adding 1 each time, which is absolutely true. And we're adding 10 each time here, which is absolutely true. And so this is going to be super important on for our class on Friday, okay? Because what we're going to start doing on Friday is actually constructing the rules, these rules that are happening, okay? And so you do have to be observant of what's happening like this, okay? For today, what's good is if you can see like what's missing and recognize the domain and the range. Okay, we did good. All right, so I'm gonna move forward. Here's another thing that we're doing today. So here it says graph the sequence that represents the situation on a coordinate plane. And it's a real life situation. Rebecca had $100 in her savings account in the first week. Okay, she adds $45 each week for 5 weeks. The savings account balance can be shown by a sequence. All right, and so we're going to actually graph the sequence, and it's going to be exactly the same thing as if we were graphing a function. Okay, and we've done that before. We've graphed functions before. And so that's what we're going to be doing here. We're going to be graphing that she started with $100. Okay, so the savings is the y-axis. She started with $100. And as the weeks progress, okay, time is always your x-axis. It's the independent variable. If you're trying to decide and you're setting up your own graph, anything that has to do with time, weeks, months, hours, minutes, that's always your x-axis. Every week, she adds $45 for 5 weeks. Okay, so look how fast I did that. So here we are at week 1, and she started with $100 in her savings account in the first week. Okay, so the first week is week 1. And then she's adding $45 each week for 5 weeks. So week 2, $45 more added to 100 is right here. Okay, this is 145. And then week 3, we had another $45. Okay, so $190 is how much she has. Week 4, we had another $45. Week 5, we had another $45. Week 6, we had another $45. And something that's important about this graph is that this graph is complete. It's really tempting when you have a bunch of dots lined up to put a line through them, but you don't want to do that with what this problem is showing here. We're showing a sequence, and so it's using these integers, these values. These are x values, or like we saw in the other tables, they'd be the ends. 1, 2, 3, 4, 5, 6. All right, we don't have midweek values that are popping up. This is something that's happening every week on the week, and so that's why there would be no line here. These are just the individual dots. Okay, so don't connect them with a line. You're going to try one. Okay, and so it says here, graph the sequence that represents the situation on the coordinate plane. Adam has $300 to donate. For the next 5 weeks, he donates $60 each week to a different charity. Okay, so his remaining donation money can be shown by a sequence. Now be careful, it's asking you to graph the sequence that represents his remaining donation money. Remaining, that means what's left. Not how much he's donated, but how much is left. He started with $300. Okay, so he has $300 to donate. For the next 5 weeks, he donates $60 each week. So when you're looking at this and trying to determine, where your first point would go, where would your first point go? I have 3 of you that have already started this. I'm going to kind of see what you came up with so far. So I have somebody here on the first, for 0. So week 0, we're starting at 300. And then week 1, we're right here where it's $60 less than the 300. So this is a good way to interpret this. And this person is starting the same way. This is what I would probably do on this one, because he's starting with $300 initially. Okay, so before our weeks even start going, he starts donating. His account balance, it's not an account, let me rephrase that. His donation fund balance is at $300. So Adam's a nice guy. He's going to give away all this money. I want to be friends with Adam. So Adam's right here, 300 bucks at 0, and then moving on. So it's tempting to do the line. Don't do the line. Just leave it as points. This is the first point. This is correct. Okay, good. So the first point at 300, then after 1 week, he's donating $60. So his amount decreases. It drops by 60 bucks. 300 take away 60 is 240, which is about right here. And then at week 2, you gotta do some more math. We're subtracting again. 240 minus 60. Oh, this is good. This person's really gotten into it. So at 2 weeks, see, I would actually shift all of this just over 1. I think that's how I interpret it. But I mean, there is a little bit of ambiguity in the way it's phrased. Okay, he has $300 to donate for the next weeks. He donates $60 each week to a different charity. So, you know, there is some ambiguity here. I wouldn't necessarily mark you wrong on that. And so here, we're moving down, down, down. It's good. So if we're starting here, so at what point do we get to 0 money left? This person erased all their stuff. I was showing it. Did you get scared? I thought it looked okay. So you guys are doing a good job on this. I have 17 of you that have tried so far. That's great. So week 1. So in here, I think I'll just type in our chat. So 300 is where we start with. We subtract 60. That puts us at 240. And then 240 minus 60, that equals 180. And then 180 minus 60, 90. $120. I'm gonna calculate. 120 minus 60. 60. 60 minus 60. 0. Okay, so we have these. We're gonna have 1, 2, 3, 4, 5 points all together. 1, 2, 3, 4, 5 points all together. Or no, we would start at 300, huh? We would have 6 points altogether. 1, 2, 3, 4, 5, 6. So if you start on the axis here, your last point should be on week 5. Because that would be 1, 2, 3, 4, 5, 6 points. Whereas, where is my person that, oh yeah, right here. So this person here, they started, you know, at week 1, which is also okay if you do that and you're consistent, which means your last point needs to be right here at 60. And so this one, we don't want to do the line. We don't want to connect the dots. He's not giving out money at a constant rate. It's a weekly thing that he's doing it, so that's why they're going to stay as points. There we go. This one's cool. Look at that. Have all 6 points. The last one ends right at 0. Perfect. Okay. Good job. All right. So I'm going to have us move forward. Now, if you're not quite done with this slide yet, it's okay. You're going to be able to come back and edit it. But I do have 2 more slides I want to show you. And then there's a video at the end that I'll probably have you just watch on during your asynchronous time before you start taking notes. So if you're still working, don't worry, you'll be able to come back. But for right now, I'm going to move everyone forward to slide 9. Okay, we're going to look at slide 9 and slide 10. And this is more vocabulary, and we'll get into this later this week a lot more. But for today, I just want to introduce it. So an explicit rule for a sequence. So the rule is like, if we're talking about a sequence that's also a function, the rule is the function, like a function rule, okay? But it's a sequence rule. It's an explicit rule when the nth term of a function of n for any whole number n greater than 0. Explicit rules can be used to find any specific term in a sequence without finding any of the previous terms. And so that's kind of more of what we're used to when we work with functions. This is an example of an explicit rule right here. F of n is equal to n squared plus 2. And so I don't have to know any of these other values, that f of 1 is 3, f of 2 is 6, f of 3 is 11, f of 4 is 18. I don't have to know the previous stuff to find out what f of 5 is. All right, if I want to know f of 5, I just put 5 here, 5 here, 5 squared is 25, 25 plus 2 is 27. All right, so that's an explicit rule. And then the opposite, or the other type of rule that we have for sequences are called recursive rules. And a recursive rule for a sequence defines the nth term by relating it to one or more previous terms. And so an example of a recursive rule is where the first value in the function f of 1 is given. You have to have that one given to you. F of 1 is equal to 4. And then there's a rule here, f of n is based on where you have something like n minus 1 or something previous. You can't figure out what this is without knowing some previous knowledge, like f of 1 specifically. All right, so this rule means that after the first term of the sequence, every term, f of n, is the sum of the previous term, f of n minus 1, and 10. So a recursive rule, you have to know what f of 1 is, okay, and then you can have it written in some way that relies on stuff before it. Whereas an explicit rule, it's defined as just f of n, and you don't have to necessarily be given something before it. All right, so just introducing that concept to you right here. And we'll make more sense of that later this week when we work more with arithmetic sequences. And so the last slide here is a video that I'll have you watch in a little bit, not right now. So we still have a few minutes, and I'm going to put this on student paste. And I'm going to kind of just, you know, as far as me explaining the lesson, that part's over. Okay, but you can still go back through here and do any of the slides that you didn't get a chance to finish, and I'll be checking that you tried all interactive slides during our asynchronous time today.